In example 5, I'm going to show you that you can also verify by working each side separately. So we're going to do some work with the left side, and then we're going to do some work with the right side until they match up. So sometimes you might have to work with both sides instead of just one side. So for this one, I'm going to start on my left-hand side. So here's the left. So I have my statement. And then my rule. And so for the first thing that I'm going to do on this left-hand side, if I look at the denominator, I have 1 plus secant x. If I look at the numerator, I have tan squared x. So I can change tangent squared in terms of a secant by using my Pythagorean identity. So the Pythagorean identity, that 1 plus tangent squared equals secant squared, I'm going to rearrange that and make tangent squared secant squared x minus 1 over 1 plus secant x. And the rule that I used there was the Pythagorean identity. Then what I have on the top is I have a difference of squares. Secant squared x minus 1 can factor into secant of x plus 1 times secant of x minus 1 over 1 plus secant of x. And factoring is just an algebraic move. Then what I can do is I can look and I can say, hey, I have 1 plus secant x and secant x plus 1 are the same thing, leaving me in step 3 with secant of x minus 1. And that step 3 there is just algebra. And I could continue on and see if I can keep going with that left-hand side, or I can take a pause and look at secant x minus 1 and see if I can get something similar on the right-hand side. So I'm going to move over to the right. And remember, there's lots of different ways to do different verifications, so just because this is the way I'm doing it doesn't mean it's the way you have to do it. But if I look at the right, move this over just a little bit. I can use my rule on the right-hand side with the 1 over cosine x. Remember, if I'm subtracting two things on the top, they take the same denominator. So I can split this up into 1 over cosine of x minus cosine x over cosine of x. And that's just algebra. And then in my second step, I can use algebra again. Cosine divided by cosine is just 1. So I have 1 over cosine of x minus 1, and that was algebra. And if you look, this minus 1 is getting similar to the minus 1 that's over here. And then finally, I have 1 over cosine of x using my reciprocal identity. 1 over cosine is secant of x minus 1. Again, we use the reciprocal. And then I can see I have the same thing on the right as I have on the left. Once these are the same, then you're done. You have proven that the two sides are the same. You don't necessarily have to get back to what you started with. You just have to make sure that those two sides are the same. If you have questions, let me know. Otherwise, I want you to go ahead and take a look at examples at the try this. When you're done giving it a try, then go ahead and unpause it and check your answer. If you did the try this, now remember there's different ways of doing things, so just because my work isn't the same as yours doesn't mean your way is wrong. I'm going to show you a way of working on both the left and the right-hand side. Again, you didn't necessarily have to do that, so keep that in mind as we go through it. If I start with the left-hand side, the first thing that I did on the left-hand side was take out my greatest common factor, which was secant squared x. And that left me with secant squared x minus 1. And just because I factored, my rule would be algebra. From there, I know secant squared x minus 1 is tangent squared x. So I can simplify this to secant squared x times tangent squared x. And if I glance at the right-hand side, I have all tangents over here. Right now I have a tangent and I have a secant, so I'm going to stop where I'm at and I'm going to see what happens if I do something similar on that right-hand side. So I'm going to come over here and work with the right-hand side for a second. Okay, and so the first thing I'm going to do is I'm going to factor out. I factored out the tan squared, leaving me with tangent squared plus 1, and that was just algebra. And then from there, I know using my Pythagorean identities that tan squared x plus 1 is secant squared. So I have tangent squared x times secant squared x using Pythagorean identity. And now you can see that secant squared x, tangent squared x, and I have secant squared x, tangent squared x over there as well. So these are exactly the same, which means I have proven or I have verified that the two sides are equal. If you have questions, let me know.